Okay, YouTube, in this video we're going to talk about the basic transformations of quadratic functions. That is, we say that quadratic functions are functions that can be written in the form f of x equals a times some quantity x minus h quantity squared plus k, where a is not equal to 0. So recall that when we talk about graphs of quadratic functions, we're referring to these U-shaped graphs that are called parabolas. So often when you talk about transformations of functions, we start with the parent function. And of course, if we were to revisit very quickly here the graph of the parent function, the idea would be if we were to make a table of values, we want to get away from this table of values. But if you plug in -2, -1, 0, 1, and 2, we get these outputs 4, 1, 0, 1, and 4 as solution pairs. But the parent function is a function that always has its lowest point. We call that the vertex of the parabola. But at the origin, so it starts at the origin, and then we have the points 2, 4, and -2, 4 also on the graph. But this is the parent function. What we'd like to be able to do is use what we know about graphical transformations. I can do this better here. Graphical transformations to quickly sketch the graphs of these functions without having to make a table of values every single time. So as we move into this video, we're going to be referring to transformations that we're already familiar with, but also trying to tie it back into this new form that we're looking at here, which is really just some a value times the squared quantity with this h value here, plus this loose constant on the end here, a, h, and k. So let us recall what we know about horizontal and vertical translations. When given some parent function here, in this case it's our quadratic parent function in either instance, we know that when you say f of x minus h here, when you put in this negative h with, or I'm not going to say negative h, I'm going to say when you put this h value in here with the x, what you're really causing to have happen are horizontal translations, okay? So kind of borrowing from this form over here on the left where we have f of x equals a x minus h squared plus k, we can see that f of x minus h being a horizontal translation, when you plug this x minus h in for x squared, you get this quantity on the inside of this squared quantity right here. So this h value truly is responsible for the horizontal shift. Now one thing I do want to point out here, and this should say y equals, but is this, it says x minus h in here. This has a negative sign in front of it, whereas when you look at the k, it has a positive sign in front of it. And that's actually very important because what I'm writing right here is when h is negative, this graph actually shifts to the left. And when h is positive, okay, h is positive, it shifts to the right. And that is what's listed down here. But when you have a function such as, say, f of x equals x minus 2 squared, what I want everybody to realize is when I rewrite this, because the formula here has a negative sign here, a subtraction operation, what we're really doing is we're subtracting off a positive 2 there and squaring it. So the value of h in this case is indeed a positive 2, even though when you look at it, you would think that it would shift left 2, okay? Likewise, if I were to have a positive in here, the same thing would be true, except for this would be negative. And the reason why it would look like it's a positive in here is because a double negative, when you're subtracting here, would make this flip back to be a positive here. So when h is positive, we shift to the right. H is negative, we shift to the left. And because we have a negative sign in the formula, it's going to look backwards. And then as far as what we know about vertical translations, we say, well, anytime you take your y values f of x and you're adding on or subtracting off a constant, then really what you're doing is shifting your graph up and down. So again, with this form that you see right here, a x minus h squared plus k, what I want to kind of point out is essentially that this plus k on the outside is really that same plus k that we had been writing this in function notation with once I plug it into the function. So f of x plus k is really f of x, which is this x squared right here, plus the k. So when we look at a quadratic function, what we can say right here is this h is always responsible for left and right shift, and this k value is really responsible for up and down shift. That's what those things are responsible for. So this is going to allow us to really quickly sketch graphs of quadratic functions that are written in this form that we have listed here, this what we call vertex form. So let's go ahead and practice this. We say describe the transformation of f of x equals x squared represented by this function g, then graph each function, and then lastly state the domain and range of the function. So let's not worry about domain and range right now. Let's just go ahead and take a look at our functions. And what I want everybody to notice is that g of x here, really we want to know what is different about g of x compared to f of x. And what I notice is that we have an h value right here. And if you ask me, well, what is h equal to? I'm going to say h is equal to -2. And the reason why is because if I were to write this explicitly in the subtraction form, it would really be this right here, minus a -2 quantity squared, which would make it look like a positive. But the fact that h is negative 2, we know that h will shift it exactly h units and in the direction that it's indicated. So since this is a negative 2, if the original parent function starts at the origin, goes up 1, right 1, this is our initial parent function right here, our initial parabola. Essentially what we're going to get here in this case is we're just going to go left 2 and then up 1, right 1, up 1, left 1, and then sketch this with symmetry here. But this would be our new g of x, and I'm going to label this is g of x. And in terms of describing what it's changed about, the parent function, is it translated, left 2 units, okay? So as far as looking at domain or range, remember domain are input or x values, and range are output or y values, okay? So when I look at this graph here, I say, well, what are the domain values? What I want everybody to know is that parabolas go left and right forever and ever, and it wouldn't matter what x value you stick into this function, you'll always get a y value back. So we're going to say that the domain for all of these is all real x, and that's true here, and that's true here for any parabola. As far as the range, we're saying what are the output values that were used on this graph. I noticed that the range values are only y values greater than or equal to 0 because these are only the y values that were used by our function here. The lowest it goes is 0, and that continues up forever and ever on that number line. So taking a look at letter B here, a little bit different. We're putting together two different transformations. We have both an h value and a k value, and I do want to list what these both are. Our h value appears to be backwards, right? But it's negative 3, and our k value is also negative 3. So using h and k as we do, we could say, well, we usually start at the origin. We're going to start now left 3 from there and down 3 from there. So we're going to start at this point, and then I will go up 1, right 1, up 1, left 1. And essentially, we're using the same thing we did here on this first one, except for we had a little bit different of a shift. Okay, left 3 and down 3. So this is our g of x. Its domain is all real numbers. And as far as its range, the lowest it goes on the y-axis is negative 3, and then it goes up forever and ever. So we're going to say y values that happen to be greater than or equal to negative 3. And then last but not least, this translation here, we notice that we have an h value. I'm going to write h as positive 2, and our k value right here, our k value is equal to 1. And so since we have a positive 2 and a 1 for h and k respectively, we're going to shift right 2 and up 1 from the origin where it would have started had it been the parent function. So we would say right 2, up 1 from the origin, and then we'll go up 1, right 1, up 1, left 1. Since we don't have any reflections or stretches, we say here's our graph. We say the domain is all real x values, and then the range here, in this case, the lowest that happens to go on the y-axis is 1. So we'd say all y values greater than or equal to 1 are covered by this graph. Cheers.